one more confirmation that people can see my screen. Sorry. Paula, yes, you can see my screen. Great. All right, I'm sorry I'm a little bit late, obviously technically challenged. Let me go ahead and get started. A few things. So I'm Ken Marten. I'm the product manager for mapping and spatial analysis at Tableau. Thanks for having me present. I hope everyone handled the weather all right in New York. I'm out here in Seattle, where surprisingly it's sunny today. With regards to the presentation, I have a few slides that I'm going to walk through, and I have a few spots where I'm going to jump into some demos. Now, if people have questions or anything like that, please just use the chat because it can get a bit scrambled if people are trying to talk and just with the connections on the sharing application. But just try to use the chat, and I'll go back to that after I've done some demos just to try to catch up on the questions if there are any. But obviously, I got to flip back and forth between presentation and demo, and then the Click Meeting application. So bear with me. I'll try and make it all go well. So for the agenda for the presentation, I just want to give a brief overview about Tableau, what the product is. I have to assume that some of you have never heard of Tableau before or don't know much about it, where some others may have actually used it before, which would be cool. I'll talk about mapping in Tableau, which is why we're all here, and road for maps. I don't like saying the map roadmap. It's like you're saying map too many times. The road for maps and sort of the long-term view at what we want to do in Tableau with mapping and location. And then we can follow up at the end with some Q&A if there's time, but we can do some of that in between, as I mentioned. So Tableau overview. So core philosophy of Tableau is really to let people who know the data ask the questions of the data, right? Tableau is meant to be truly a self-service analytics application and platform. So with Tableau, the traditional target for the application has been sort of your business user, like someone in marketing or sales or finance, those types of roles. Not so much, we might say like an advanced GIS person, right? But of course, with Tableau, we really view sort of the democratization of data and analysis. So regardless of sort of traditional roles, we want to make a tool and platform that can support working with any type of data. And if we're talking about spatial data, you may have heard this before, but obviously spatial is a little bit special. It's not just numbers and strings and dates and those kinds of things. And we've done some work recently to really elevate and make spatial first class in Tableau, which I'll show you a little bit about. As far as the product suite, so there's Tableau Desktop, which works on Windows and Mac. We have Tableau Server and online just a hosted version, supporting Windows, Linux, AWS, really flexible deployments. Then there's Tableau Public, which is a free-to-use application and part of the platform. Allows really easy sharing. A lot of people with sort of open data, open analysis type of policy use Tableau Public to share a lot of visualizations, as well as in academia and so forth. Tableau Reader is, as you can imagine, just the read-only version of Tableau, basically allowing you to open up people's workbooks, view them and interact with them. But you're limited with being able to make any modifications or save workbooks once you're using them in Reader. And then we have a Tableau Mobile and a new product coming out called Maestro, which is a data preparation product. So it's sort of in the same space as Safe Software's FME, or if you've ever used Alteryx. It's really a powerful ETL tool, and Tableau's view of this tool is really to make what we've done with modern BI, sort of drag and drop, very intuitive and easy to use application, to bring that same philosophy to Maestro and make data preparation and cleaning of data really visual. So that's something to look forward to. And then just to give the, this may be obvious, but Tableau is not just about maps and spatial data. And in our last 4 releases dating back to Q2 of last year, you can see all these types of feature updates we've added to the product. 10.2, the #1 feature there at the top was support for spatial files, which I'll show you during the demonstrations, is just one of the many features added. But again, we're looking at security and data governance and certification of data, analytic features like adding trend lines and things like this. So again, the full sort of spectrum of doing analysis and working with data at Tableau, we're working on all these fronts. I'm just responsible for the one particularly interesting front, which is mapping. So here we are, mapping in Tableau. What can we do? So with maps in Tableau, sort of the starting point for most people is using Tableau's built-in geocoding and sort of built-in capabilities, right? There's a lot of things that you just kind of get that work very easily in Tableau. For instance, if you have geographic place names in Excel tables or text files or non-spatial tables, you should be able to map those in Tableau without a problem. And Tableau supports standard administrative boundaries across the world, zip codes for over 50 countries, area codes within the United States, congressional districts, CDSAs, and MSAs within the US as well, but also cities globally and airports, and a few other things. We also support custom geocoding, the ability to extend some of these roles, because there are a few little thresholds that we have, especially related to cities. Again, we don't have every single town and city built into the product, so people can extend that role using custom geocoding. People more commonly will add their own custom role. So if they have like a custom sales region, or maybe they want to map out the ports of the world or railway stations or something like that, they can add a new geographic role to Tableau. I'm just going to pause here for a second and make sure there's no questions on the chat and everything's going well. Only slightly paranoid. No one is complaining in the chat. I'll go back to the presentation. Yeah, so we have all these built-in geographic roles. And then we added a new feature called custom territories, which allows you to aggregate some of your geographic data into new roles. For instance, if you build sales territories off of zip codes, you'll be able to create those in Tableau without having to have a shapefile or something like that. Or if you want to map, say, things like the European Union, right, which is made up of 20+ countries in Europe, as a single entity in Tableau, well, you can just group the countries that are a part of the Union and make that new EU, and then outside of the EU geography in Tableau. As far as background maps go, Tableau has built its own map service, and we support 3 basic styles: a light, a dark, and like a normal cartographic style, we call it. And we also have demographic data built into the product for the United States, with over 30 variables that you can use as a background layer for your map. We also support connections to WMS servers, Mapbox, and of course you can connect to ArcGIS server when the services are WMS capable. And I'm going to show a way in which you can do that when it's WMTS capable. But WMS and Mapbox you can connect to very easily out of the box. Slight configuration to work with WMTS. And it doesn't need to be an ArcGIS server to work with WMTS. I'm just going to highlight one of those examples. And then, of course, you can actually have geographic maps by using background images as well. So I'll give an example of that. So let me jump into some demos, and we'll go from there. Oops. Here we are. All right, so this is Tableau, a worksheet, a blank canvas. Now, many of you, I have no idea. I'd ask you to raise your hands, but obviously we're all remote. I mean, I don't know who's seen the product before, but I'll give you a little lay of the land. Obviously, here in the middle is where visualizations are going to be created. I can drag and drop fields on here to start creating a viz. At the top, I have rows and columns, which is just a way to define the axes of the viz. For maps, you're always going to see latitude and longitude up here in some form. And then the marks card, ways to control encodings, and then a number of cards, filters, and pages, ways in which you can kind of slice and dice the data. So in this first data set, I have election data from the 2016 election for the state of New York, broken down by congressional districts. Let's take one little look at the data. So here I'm looking at the schema view. I click data source down here on the left. And I'll just highlight a few things. The CD field is the actual congressional district in New York. And then you'll notice that there's also a county breakdown within the data. You can see for the second district, there's part of Nassau County and Suffolk County contribute to the second district. So I have data based on that. But you can see that's going to create an aggregation problem, right? If I have multiple rows for an individual entity, well, how's that going to map? I'm going to need to do something to aggregate that data. Well, the cool thing in Tableau is that Tableau does aggregation automatically. So here I have that congressional district role. I can just double click it and it creates a map showing those points. And I can change the points to be boundaries. I could add CD to color. And here are my congressional districts in New York. All that is built into Tableau. I didn't need to connect to a spatial file or anything like that. This is all just from an Excel file which I downloaded from an open data site from the New York government. Now another thing I want to highlight here is let's take some of these fields back off. Again, I can just drag and drop to sort of move around. And here I have the state field. And now I'm actually showing the counties. So I actually have a geographic hierarchy here of state, county, and congressional district. But congressional district and county, they don't map as I explained. So there's no point in drilling down below county to see that. But again, I can drag county out here, and here are all my counties. So what I'm showing you here is that Tableau has a number of geographic roles built in. Congressional districts and counties are the examples in which I'm showing you. But if I click on the actual indicator for the field type, you can go to geographic role and see all of the roles that are supported. So if I have airport codes, whether they're ICAA codes or the standard three-letter airport codes, you can map Tableau and then so forth. So obviously for countries, your countries, states and provinces, again, if the country in which we're geocoding for doesn't have a state or a province, we've mapped the equivalent entity into this role. The same for county. In many places in the world, they don't have counties. They might have a district or a prefecture, things like that. So yeah, now that I have my congressional districts mapped out, or let me bring those back on. Bring them on here. Remove counties. What might I want to do? Well, let's say I work for the Democratic Party in the state of New York. Well, I might want to look at how the demographic voting pattern was within states. So I can look at the percent of votes that were Democratic, and you can see some of the dark spots down here are just showing me that this is where the Democrats did well. And obviously lighter spots are where the Democrats would need to maybe make some inroads, right? So it's very easy to sort of move measures, this category of numeric fields, things that I want to aggregate onto the viz. I sort of got away from that point I wanted to make, but that aggregation is happening all the time on measures. So here there's automatically the sum applied to this field, but I could easily change that to be count, median, average, depending on the type of numeric data I'm looking at. In this case, sum is fine. I could also look at wind strength. Again, these are some fields that I calculated off this data set. And now I get a better, it's sort of an inverted view of what I was just looking at, right? Here, that area that I highlighted, that's where I said that the Democrats might want to look to make some inroads, was the area that was strongest with Republicans. It might not actually be the first area that the Democrats would look at. They might want to make, go to an area in which the Republicans barely won and try to tip the scale in their favor. So this is just an example of mapping that out. And here I'm using color to encode both, which party won that congressional district and sort of the intensity of the color showing the strength. So it's sort of a dual encoded way of looking at this viz. and that's just built into the data set. So that is just sort of out of the box mapping in Tableau. Bring in a field with a geographic role, and it will map. Now, the next example I want to show you is for healthcare data in the state of New York. And let's jump to this data source as well. So here you can see that this data source, it basically has like expected outcomes for people who are visiting hospitals. I don't actually know all of the data set, what it actually represents specifically, but I pulled it out because I know that healthcare data in the US is often looked at at an aggregated level as well by the first 3 numbers of a zip code. So here I can see I have 3-digit zip codes available to me. Now what I'm going to do is add a table that I have, includes all the zip codes for the United States, and join these together. Now I'm going to use that zip code field from my medical data set. And here I only have a zip5 field, so I can't join these 2 tables together. But one thing that Tableau allows you to do, again, it's very easy to work with data sources, is I can create a join, and then I can create a calculated field and then create a join off of that. So here I can say left, I'm going to choose zip5 in the first 3, and I'll say OK. And then I might need to change this guy to be string, and there the data set is now joined. I don't have any errors. Now I can go to my back to my visualization, and what I'm going to show you here is one of these interesting things you can do in Tableau. So if I want to make a geographic hierarchy, I can just select a few fields, say create hierarchy, all the zips, and the zip3 is sort of the parent to the zip5. And I can double click on the zip5 and I can see all the zip codes within New York State. Great. But remember, the data I have is aggregated to the zip3 level, right? So I need to be able to map that. If I show you what zip3s look like, something went wrong, right? Well, in fact, it's saying the geographic role for zip3s is zip code. It's not actually zip code. It's based off of zip codes, but a 3-digit code for zip code is not supported in Tableau. But because we know it maps to the underlying 5-digit zip codes, we could say create from 5-digit zip code. And this allows you to create that custom territory that I was referring to. And just like that, now it's actually geocoded all of the zip3s, or made that geocodable. And now it's color encoding all of the zip5s by the truncated zip3. Now if I collapse that, one thing I could do, actually let me do this, it's a little more dramatic. Go back to zip5, I'll change it to map, and now I get the filled version of all of those entities. And you can see it renders really quickly. And now if I collapse it, you can watch closely, it actually dissolved all the interior borders for all the zip codes. Now zip3s are a little bit messy. You can see they kind of, seems like they overlap in some way. They don't. But there you can see that I've taken all the zip codes for New York State, truncated them to the 3-digit zip code level, and created this new custom territory, which is essentially like a healthcare referral zone or referral region in the United States. And then I can take one of those fields that I was looking at earlier, like Medicaid hospitalizations. I think this has something to do with basically, let me bring my 3-digit zip codes back onto the viz. And this has to do with expected hospitalization after you've been treated, so like within 30 days or something like that. I believe, could be wrong. But you can see I can just bring on any one of these vizes and just replace that data set. And depending on the structure of the data, you can see here there are actually values plus or minus 0 in the legend. You can see the color palette also is chosen automatically to be a diverging color palette. So Tableau is trying to automatically present the data in the best way using the visual best practices. So there you can create custom territories in Tableau based off of data supported by Tableau when you have it mapped sort of in your data. Again, I could have sales territories, and my regions might be north, east, south, and west, and they're made up of all the states. Well, I could just easily map those out and define the role in Tableau to be based off of state, and then I could map those custom regions. Here I'm going to show another example. Let me start from scratch a little bit. This data set is about invasive mollusks. I know it's a thrilling topic for most people, but these are like zebra mussels, and these mussels that have invaded, fresh waterways, and certainly been really newsworthy thing in the province of Ontario and in New York State. Now, with this data, I don't have anything built into Tableau to support this for mapping, right? I need to bring the longitude and latitude information to actually be able to map it. Now, once I've added lat and long to the viz, you'll see an odd thing, maybe. There's only one dot. Now, why is there only one dot? Well, that's because Tableau is aggregating it's always aggregating measures by default. And latitude and longitude are just numeric fields, and they're special because they're geographic. So we knew to make a map. But in this case, you might want to turn off aggregate measures. Or the other way to think about it is just to always define the level of detail of the viz. Now, do I want to see every individual sighting of one of these invasive species? Well, I can just drag a unique identifier onto the level of detail, and here they are, right? I can see them kind of spread out across the U.S. and southern Ontario and Quebec. Now, if that's not what I want to look at, say I want to aggregate the data by like the county level or the state level, well, I can do that as well. I can just simply bring state onto the viz. That brings that geographic hierarchy again. And what I can do from here is I might say, well, why don't you show me the number of records, right? A field that's provided by Tableau based on these states or counties. Let me up the size a little bit, and you can see it. Now I can see, which states have the most sightings of these mussels. What I want to do now here is I'm just going to take Canada out of the picture. I'm Canadian, so don't worry. It's not that I don't care, but just for a simpler view of this data set. I can just drag the country field onto filter, uncheck Canada, and say OK. And now I'm looking at just the United States. Now, of course, if I want to break this down even further, I can go from state to county, and I get this really detailed view. Let me move over here to New York State. And again, now I'm looking at a proportionally sized symbol where we're seeing invasive species by county within the state. So this is pretty interesting. Now, what if I were to drag, what if I want to see sort of how this pattern changed over time? Well, one thing I can do is bring year onto the pages shelf. And here we are in 1988. Now I might actually have to jump back to the full extent of the data. And I can see the first, reports here are starting in Lake Erie and down towards the Michigan border. So what I can do is I actually get this time play feature from the pages shelf. I can just press play. And I'll start to do that, and you can see how things change over time. And you get this sense of spreading and in some cases large numbers, certainly in New York there for a little bit. I'll stop it there. Another way in which I can represent this data too is, well, let me bring the name of the species onto color. I want to separate zebra mussels and quagga mussels. Those zebra mussels are real nasty, and I want to keep an eye on those. And then I want to, I'm going to bring this back to the start. I'm actually going to turn on show history. Show history for all the marks. And then I'm going to zoom in just to the northwest, not just the west, but the northwest. So we'll take a peek from that. And then press play. And you can see Tableau is really presenting the spatial pattern, but it's maintaining the history of the data set as well. And that history just sort of fades a little bit more, becomes more transparent as I move through the time series. So this is a way in which Tableau allows you to animate visually through a temporal data set and show you a spatial pattern, give you a sense of the distribution of these events. So that's a little time series exploration in Tableau. I'm going to keep moving along here because on that slide I said I was also going to talk about background maps. Now here I have a data set right here of police precincts and crime for the city of Columbus in Ohio. Now this came from a shapefile, and when you connect to a shapefile in Tableau, you always get a geometry field. And with that, I can just double click it and bring it onto the viz. And this, Columbus has these really irregularly shaped and sort of, just sort of a strange pattern for police precincts. But there they are. They are the real thing. And I'm just going to set the level of detail of this to be the police precinct so that I can hover over any individual mark and they're not aggregated together. Now with this, you can see the background map is a little bit sparse. Now in Tableau, I have some choices I can make. I can go in here to our background map sort of definition, and I could turn on streets. This would be one thing that would sort of help set the context for this data. But what might be more interesting is if I were to connect to my own service. If I work for the city of Columbus, and in this case, I know the city of Columbus has a publicly available map server which we can connect to. Let me just jump out. I'll go back here and just show you that this is the ArcGIS REST services directory for the city of Columbus. Now, I went through here and I found a base map that is WMTS capable. So long as it's WMTS capable in a supported projection, I know this might be a topic of discussion because I know a lot of the New York data sets were in state plane and I wasn't able to, or they were in a UTM zone 16 or something like that. I couldn't connect to them when I was trying to get it to work yesterday with the New York data set. But in this case, I can look at is the spatial reference here is 3857, which I know is supported by Tableau. Now, what I can do is jump back to the product. Now, Tableau comes with a Tableau map service configuration file, so you can connect to basically any map server that supports standard types of requests, like ZXY requests, tile requests. And I've already gone ahead and made that configuration change. So here I've added ArcGIS, the Columbus base map, to my Tableau instance. Again, I'm saying not everyone gets Columbus out of the box. I had to make this modification to this configuration file. But once I choose it, you can see now I'm making a connection to, if I work for the city of Columbus, much more relevant data set and sort of the standard that my organization works with. This is a way in which I can connect with an ArcGIS server or any WMTS capable map service. Great. And then from here, I might want to look at where crimes are happening. Again, I'm going to use number of records and put that on color, and I get see here that precinct 6 has the most crime. Now from there, I'm just going to bring some crime analysis together just to show you an example of how you can make an integrated view in Tableau. I've done a little bit of pre-work here to set this up. So here I'm just looking at trends in crime. This crime data set that I'm looking at takes place basically over a month between the end of August and September of 2016. And I have basically the trend lines, or I have the actual data for each precinct, and then trend lines to associate with those things. It looks like a bit of a mess right now, but don't worry. And then I have a look at the most common crimes within the city of Columbus. So here I've built a viz where I have police precinct on the columns, and you can see them all here at the top, and the type of crime here on the rows. You can see them here. And I've actually filtered this data set to show me only those crimes where there have been 20 or more incidents, just so I can look at sort of like the major crimes of the area, or the most common crimes of the area. And then I have this dashboard. Okay, so now I have an integrated view of these three data sets. But what I can do with the map, because a map for so many people, like you GIS folks will know, is the thing that kind of everyone gets. I know where my precinct is. If I'm a police officer and I work in the 6th precinct, I know where that is, and I can use this map as the interface to work with it. And I also like to see things in relation to that as well. But what I can do in Tableau is just use this little command off of any sheet that I've placed on a dashboard called use as a filter. And now this map is going to drive actions inside of the dashboard. So if I choose the 6th precinct, here I can see the individual data as it shows for the 6th and its trend. Of course, I could actually change the trend to be linear, and you would see this line just look like, a rocket ship going out to the right. But that's probably not a true indication of crime in Columbus, that is just skyrocketing out of control. And here I could just, again, click around to different precincts where I'm interested in. And you can see the whole dashboard here is starting to work together. There are many ways in which you can integrate interactive capabilities between different visualizations. I can make any one of these other visualizations a filter. I can also create actions that allow me to select things in one viz, like I'm doing here. And they will either filter or select related records in other visualizations. So there are many ways in which you can work with visualizations together. Let me just do a quick time check. 9:35. As expected, it's going to be hard for me to get through all this content in an hour, but we will go as fast as we need to. I'm going to go back to the site and just make sure, see if anyone has questions. So that's sort of the first little segment of mapping in Tableau. All right, I'm back here on the chat. I'm just going to take a few minutes to answer questions. Jason Baum asked, we have an authoritative geocoder here in New York. Can we fold that in as a default? So there's no way to leverage your own geocoder in Tableau yet. It is one of the things that our team has. I'll give you a little bit of background. Our team has made it flexible enough that we could swap in a different geocoder. We just haven't prioritized that work at the moment. So that's something that we're interested in doing. I'm curious, Jason, if you could just say whether or not it's an ArcGIS geocoding service, or if you built something else custom, or you're using a geocoder through some other service. How many map services can be used at the same time? So you can only use one connection to a map service at once. Of course, if the service supports, n number of layers within the service, you can get all those layers exposed to you. Any plans to be able to pull in WFS for either analysis or mapping? Asked Matt Downing. Yes, there is a lot of discussion about support for web feature services as the data source from marks in Tableau, the actual data that you could interact and encode and do analysis on. We actually have had some plans here at Tableau to support a web data connector. It's not officially set with a timeline and release, but it's definitely a high priority thing for us. So WFS or an ArcGIS server feature service is definitely something that we've discussed. New York GIS Association, is there a way to adjust a map legend to use different classification methods than the default, such as natural breaks, or quantile? So make sure that I follow up with some resources. But out of the box, there isn't a set of choices that are common in GIS applications, so there's no way to pick natural breaks right out of the box. But you can make some calculations and basically build the data to bin the data as you see fit for classification. We have lots of documentation written about this, or some blog posts. Community's done some work to blog about this. Make sure that I share resources back with the group. I'm not sure how best to do that, but you'll have my email, and you can always email me, and I will get you the right resources. I can also say that that's also something that we're interested in doing in the future as well. Okay, so those are those questions. Thank you, Jason. I got your ArcGIS geocoder response. I'm going to go back in here just to the deck, just to make sure. Oh, I forgot to do the floor map, so I'll cover that example. And then I'm going to talk about a few more examples around spatial data sources. I've actually shown a few of those and other things that we can do. So let me just jump back into the demo. I'll try and go for 15 more minutes. I'm not sure how much time that's really going to give us. And I hope this is going all right for you. But we'll see how far we get. So yeah, I talked about background maps. And the other way in which Tableau supports sort of out-of-the-box integration with other mapping services is through Mapbox. So I'll give an example here of offshore wells. This is in the North Sea, and you can, around the world, obviously offshore drilling is a popular activity amongst large oil and gas exploration companies. And what's important with respect to sort of this stuff is you often have custom layers that you want to have for context. So in this case, I can go to Background Maps, Map Services, and connect to a Mapbox map that I have custom layers built in and some custom styling that makes sense for my organization. So here I can say add a Mapbox map, and then I'm just going to choose offshore as the name. See. And then I can paste in a URL if I get from Mapbox. Here I've actually, let me see if I actually have it up here. So here's my offshore UK map. This is my Mapbox account. I could say share, develop, and use. And when it says down here using GIS style apps, you can actually pick Tableau. And I can try to copy this. And then I can just jump back to Tableau, paste in that URL, and hit OK. And now we see the map updates, and I see some new layers within the map. So I'm actually included here offshore boundaries, nautical boundaries. And then if I, sorry, that's a little bit spazzy. Zoom in a little bit. You can see now that this set of grid blocks is showing these are sort of offshore leases, areas where you can lease for exploration. And then I could zoom in a bit further, and I have labels turned off. So here I just interact with the map. I have no idea if this is coming across all right over the remote. But of course, I can see all my flow classes here. You're into offshore drilling for this region. It's a circle mark type. And then I could turn off aggregate measures. I'll zoom back into that area. And again, it's really easy to sort of toggle and play with the data. But this is an example of working with a custom Mapbox map in which I've added a number of custom layers, the labels for the lease blocks, and these nautical bounds offshore exploration. And of course, I'm mapping my own spatial data set on top of that and just place a simple encoding on it, and I can start to work from here. So that's Mapbox integration there in Tableau. Now with floor plans, sort of a non-geographic view, let's go ahead and build this out. So here, I'm going to turn off aggregate measures. You can see sort of a regular pattern amongst these dots. These dots represent the locations of rooms on a hospital floor. Now, I can go ahead and add some hospital floor data I have, and it's going to make that join based on the room number in each data set. I'll go back to my floor plan, and what I can do is add a background image. I'm going to choose floor plan, add image. I'll browse to this. Pick my floor plan PNG, open that up, and hope I can enter the number of pixels in this image. See if that works. Okay. So here we are. I'm actually going to choose shapes. I want the filled circle size, make that a little bigger. And then I can go in here and say, room data here, minutes and ED. Again, I now have a quantitative data set. I can see some darker values for more time spent in the room and lighter values for less time spent in the room. And then I can change up again for, again, a different measure, right? I'm just showing you sort of easy sort of drag and drop use there. But basically, in a nutshell, I have a floor map. Now this could be, a basketball court if I want to do some sports analytics. This could be a manufacturing floor. if I want to look at interior sort of processes and equipment failures and related things like that. I've also seen people, map out the human body and anatomy and visualize other types of like medical and biological data sets as well that way. So it's yeah, it's an interesting use for Tableau. Fairly simple to get started going this way as well. The next thing I want to show is this way in which you can work with census data. Now, I'm sure most of this is the GIS group. Everyone's familiar with the census and American Fact Finder, and just how useful those data sets are. Well, I'm going to go ahead and add a spatial file that looks at census tracts in data. I'll open that up. And I'm going to go ahead and make a connection to a mobility data set, so basically where people are moving within the state of Virginia. And I'm going to use GeoID and GeoID2. Okay. Left join to make sure everything is in the data set. And I'll jump to our worksheet and add the census tracts. So you can see once you've downloaded data from the census and from the fact finder, it's very easy to integrate the data sets and bring that into Tableau. Go ahead and use the GeoID as the level of detail it is. And from here, there's something I wanted to show you that I think is pretty neat. And just in the interest of time, let me say I want to look at which counties, or sorry, which census tracts have ability, right? So move from a different state. Let's bring that onto the base. So here I know it's a little bit small on your view, I'm sure, but I can see definitely some pockets here where there's been high mobility and the rest of the state relatively low. But what I want to do is find out which ones are above average, right? It's hard to sort of pick that out, and I can't just drop an analytic object in Tableau. We actually have an analytics pane here that allows you to draw things like averages onto bar charts and whatnot, but it doesn't make sense on map. So what I'm going to do is create a calculated field, and in this case, I'm going to say average mobility. Now the interesting thing here is I want to find out which census tracts are above or below the average for the whole state. Now, if I want to use the whole state, well, that's a different level of detail, right? Census tracts are below that, and the whole state would be above that. Now, how can I create a calculation that's going to allow me to look at the actual value of an individual census tract against the average of all of the records, all of the other 1,900 marks in the data set? Well, Tableau supports what's called a level of detail calculation. And I have one here that I built earlier. I'm just going to grab it out here and paste it in, and I'll explain it to you in Tableau. Of course, it contains errors for some reason. It makes me feel good. But yeah, we can make lots of different types of calculation statements in Tableau. Pretty standard. But in this case, I'm saying if the total of moved from a different state is greater than, and we have this key term fixed. Fixed is like, take me to the level of detail above. Fixed for the state field, and I want to take the average of the same field, estimate total, moved from a different state. But of course, that at the state level, it's going to include all of the values. And then above average or below average here. Undetermined string. Terminated string usually means you're missing a bracket or something. Here we go. Didn't like the apostrophe, the way it was pasted in. It wasn't my fault. So I'm going to go ahead and say OK. And now I'm going to drag this average mobility onto the viz. So here's the interesting question, right? If I drag this onto color, what's going to happen? Well, I'll show you. Well, I get two colors, right? You're either above average or below average. But I lose that quantitative sort of indicator that I had before, right? I could see there was definitely a hot spot for mobility, but now I don't see it. So let me undo that. And I don't want to go back and forth with undos, but I can take my calculated field, wherever I placed it here, average mobility. I'm going to drop that on the tooltip. And what I can do is I can actually click on the value in Tableau. And here's the default tooltip. And what I can do is I can actually click on any categorical field within the tooltip. So when I click above average, it gives me this way in which I can explore the data without losing the context of my exploration. Again, you configure data sets to have different bins, different values, and this is another easy way in which you can look at one variable but use another type of indicator to sort of drive your analysis. So I think that's a pretty cool trick, working with a level of detail calculation to calculate against the full aggregate of the data, and then just ways in which you can interact with the tooltips. Of course, I can actually put in separate visualizations into the tooltip now in Tableau, so there's lots of flexibility you get with tooltips. Let me just check the time here. It's 9:51. People, I'm gonna cover a few things here. I knew this might happen, so I'm just going to jump to some finished workbooks. So here, Tableau supports bringing data in directly now from SQL Server databases. There are a few limitations with it in terms of spatial references that are supported and whatnot, but now you can leverage the spatial ops that are included in the database. So in this case, I've made a connection to a SQL Server database. When I go and look at the data source, you'll see that I actually made a custom SQL query, fairly simple. I'm just asking for these fields. One of these fields is a buffer. It includes a parameter from Tableau to define how big that buffer is. I'm actually going to join the two tables based on a spatial intersects operation. So I go back to the viz. Here I've built out the results of that work. You can see I have these gray buffers around schools, and my analysis is to look at parks within a certain radius of schools. So I know where school kids have access to parks and get a sense of just sort of neighborhood amenities with relation to parks. So here I can click on any school and just sorry, I meant to just highlight on it. Move it around. I can sort of visualize the parks that are inside it. I can change this radius value. Here I have a radius set up here. Now, this query is going to execute each time I change the radius. But now if I go back and forth, you can see that we're actually caching the query, so it's performant. And as I move and explore different values of the radius, you're going to be able to see that update. So I'm dynamically changing this buffer. Let me choose something like 600 to make it a little bit more dramatic. And then I'll show you one more thing that I did as well. You'll notice that the buffers that I've placed around the schools are in some cases cut off at the edge, right? So I've actually used a calculation to perform an intersection against the database as well. So here you can see it's pretty simple as well. I just put in a placeholder. The %1 and %2 are replaced by the school geometry and the park geometry, and then just applying a buffer to that as well. Of course, I'm using intersections, so it's going to slice it like it does, so it doesn't go outside the buffer of the school. So here, Tableau now is reading spatial data directly from SQL Server, and with respect to databases, this is something that we intend to continue to add more database support, so like Postgres or Oracle or Teradata, others that our customers have asked about and that we know are important, most widely used types of databases. We actually surveyed a large number of customers who we know work with spatial data in Tableau, and out of spatial databases, SQL Server was the one that they used the most, which is one of the reasons why we wanted to build and support SQL Server first. But again, this is sort of on our list of things that we have to do roadmap. Now, I wanted to show you a couple future things. Now, I don't know if I have the visualizations already built, but if we're talking about roadmap, in the second quarter, so just maybe less than a couple months away, we're actually going to support Spatial Join in Tableau. So you saw me performing that intersects in the database. Well, now with Spatial Join, I can support intersects across shapefiles, non-database data sets, or with a database table and a shapefile or something like that. Why don't I just go ahead and give you a quick example of this. Let's see if I have. Yeah, I can do this one. I'll do this quickly, and then I'll go back and try to answer some questions. So here I have Japanese river basins. Of course, I'm back to wildlife biology again, but it's okay. And waterfowl sites, so I'm looking at ducks and related things. And here, there's no common attributes between two data sets, but I can choose intersects as my join operator. And now when I go to the waterfowl dataset page, I can bring out the basins. So it's executing that spatial join. I can bring out the ID just to disaggregate the data. And then I can bring out a number of records on the color. So here I've mapped out waterfowl by river basin within Japan. These are obviously all custom data sets, about 20,000 records of bird sightings and these complex river basin polygons for the rest of the country. Wanted to, I could actually make this a dual axis map and take the geometry off of this, and the ID, the number of records, and I'll add the waterfall sites. Change those to little circles. And I'll add an ID. To disaggregate the data. And then I could add species by color. And there's probably going to be lots of different types of waterfowl in Japan. And then I can use a dual axis so that I can map these on top of each other. So again, that's a way in which you can work with multiple layers within the same visualization via the dual axis mechanism. So I'm going to jump back to the deck or to the chat room and see if there are any other questions, and try not to apologize too much for taking up all the time. Okay, so we have about 2 minutes left. How can I visualize multiple records that share the same latitude and longitude coordinates? Scenario, building has 10 leases. How can I visually show the 10 leases on a map? Asked Aaron Walter. Yeah, there's a way to do this. It takes a little bit of data preparation to do it. There's no out-of-the-box, press the button to disperse the records kind of tool in Tableau. But you can do a little bit of preparation and make this happen. I can, again, provide a blog post or some intricate documentation with examples on how to do this. And I'll share that with Colin, who's organized this, and he can post it to the website. So, man, I didn't get through nearly any of this other stuff. But while you're still on the line, I'm going to show you a few more things because we're here. I want to show you a few examples, sort of best cases. Tableau Public, the city of Cincinnati has a whole insights gallery in which they've built visualizations for their city. It's really, really popular and as an example to show off. Lots of different mapping examples and different types of visualizations created here. Cincy Insights, check that out. We also have a lot of students using Tableau, and here I have a visualization that actually won an award from Tableau as the top student entry. It's just loading here for a second. I know it's kind of a complicated look at zip codes and traffic counts, but another way of looking at this data is also through hex bins. You can create hex bins via calculations in Tableau, and this person's aggregated traffic violations over this area in Maryland. And then another way I want to show off sort of how people can use Tableau is this long form sort of storytelling. It's almost like a National Geographic type of article. It's really a beautiful visualization. Lots of examples of this on Tableau Public. And again, I can share links to all this stuff. And yeah, so with that, I will try to answer questions until they, I guess we're out of time, but there's one more question. Is it possible to add a shapefile or feature class polygons to map that can be used to spatially query the data? Is it possible to add a shapefile or feature class polygons? I'm not quite sure what the question is being asked for. If this is like a spatial join, or if this is a specific type of query operation. Matthew Koberger, similar to wave reference layers for Power BI. I think I know what you mean. Yeah. So there's not like an out-of-the-box operation that you can use one boundary to execute against another, but using intersects, again, data a little bit, you can get something similar to happen, but nothing directly out of the box yet. That's also, advancing spatial analysis in the product is one of the things that we want to do as well. So thanks for the question, Matthew. I know I gave you a short answer there, but I'll provide more material to Colin, say thank you to everyone for joining, and I'll do it again, and hopefully they give us an hour and a half, and we'll do even more stuff. Thank you, everyone. I'm going to sign off. Have a good day.